We are NVIAS Engineering. Team members are Edgar Ruiz, Norma Ramirez, Vermina Chow, Ian Bernados, Andrea Weckel, and Zoe O'Randall. Our project is the redevelopment of the County Livewell Center with an emphasis on sustainability. Our team was tasked with redevelopment of the County Livewell campus. The new facility will be a multi-story, 220,000 square foot building able to serve up to 800 staff and visitors. A new parking structure and entrance will be constructed to accommodate the facility's increased parking demand. Additionally, 3 acres of the site will be set aside for a separate future affordable housing development. In addition to the county's request, a recycling system will be incorporated on site to collect, treat, and reuse both graywater and stormwater runoff to supply the building's irrigation system, green roof toilets, and urinals, as well as achieving LEED Gold status. The project also includes other water, wastewater, and stormwater components, along with geotechnical and construction engineering analysis.
In the existing conditions, the majority of the site's surface is impervious and stormwater flows into the city's stormwater conveyance system without treatment. This degrades the water quality in our oceans, rivers, and bays. So for the proposed site, we plan to capture and treat stormwater prior to its discharge to the city's stormwater conveyance system. The left image is an aerial view of the site on the western side of the existing facility. As the arrows show, stormwater flows directly to Rosecrans Street without prior treatment. The right image shows the weep holes in which stormwater flows. As you will see later in the presentation, our sustainable design includes swales to treat water prior to its discharge. Our sustainable site design includes a cistern collection system. After conducting a feasibility study per the City of San Diego stormwater standards, a 3,000-gallon cistern was determined most feasible for irrigation and toilet flushing. A potential savings of up to 42,000 gallons per year is possible during a typical wet year. Per the County of San Diego's hydrology manual, the rational method was used to determine peak flow values. As you can see on the proposed drainage plan, the site was divided into different basins. This was necessary to determine BMP sizes and to ensure a majority of the water was being captured or treated prior to discharge to the city's conveyance system by diverting stormwater to appropriately sized swales. The swales are shown on the east and west side of the facility, and the diversion system to the cistern is shown on the red circle.
BMPs use governing principles of low-impact developments, also called LIDs, to conserve natural resources while minimizing and disconnecting impervious area. Site LIDs serve several uses, including retaining a portion of stormwater, providing enhanced infiltration, and increasing hydraulic residence time of water before being discharged into city conveyance systems. They also reduce soil erosion, carbon dioxide emissions, and the heat island effect, all while being visually appealing. BMPs for the site include vegetated swales, impervious dispersion areas, a green roof on the main Livewell Center, and perimeter parking and bioretention in the surface lot. Both of the swales and dispersion areas met the drawdown time criteria of 36 hours or less. The total impervious area of the proposed site design is 122,500 square feet. The use of site LIDs has resulted in an addition of 14,450 square feet of pervious area. This results in a final difference of impervious area of 65,601 square feet, or a 34.8% decrease. Through use of these permanent stormwater BMPs, the redevelopment site is able to achieve LEED Gold accreditation in the sustainable site category as shown in the table below. Not only do these make the site more eco-friendly, but they also offer a refreshing outdoor area for the community.
The average potable water demand of the building is found to be approximately 230,000 gallons per day. This was calculated based on the capacity of the building and its use. Maximum demand of the building was found to be approximately 600,000 gallons per day. Now, the fire demand of the building is approximately 4,000 gallons per minute. Based on the fire demand that's needed for the area of the building, there should be 4 fire hydrants that the building has access to. This is based on the California Fire Code. It is recommended that the size of the pipes for the potable water main should have a diameter of 6 inches. The size of the water meters should be 1.5 inches. It was calculated that the average dry weather flow for sewer sizing would be 120,000 gallons per day, with the peak flow being 330,000 gallons per day. It was calculated that the diameter of the sewer lateral should be 4 inches, while the diameter of the sewer main should be 10 inches, based on city regulations. On the left is a potable water pipe design. As you can see, the water main pipes are on the outside of the boundaries. On the right is the sewer pipe design. The sewer main is also be on the outside of the boundaries, while the sewer laterals will be connected between the buildings and the sewer main.
Envias Engineering has implemented an on-site gray water and stormwater recycling system.
This exhibit shows the entire treatment system to scale, residing in the basement. This schematic shows the reclaimed water distribution system and will aid in earning the protocol status with water laboratories and when routine repairs, groundwork and dry basement shortages occur. More treatment is shown to be added. Huge gray water given large amount of space of sensor pumps attached to the distribution storage tank. From pipe diameters, water goes in according to the 2012 International Plumbing Code and is then listed in the adjacent table. This tank allows for a uniform pumping rate of water into the distribution system. The system was sized to handle a peak daily wet weather flow of approximately 3,300 gallons per day.
The geologic and earthquake engineering part of our report is prepared to respond to the requirements of California Building Code, Chapter 18. The investigation was based off of exploratory boring testing conducted by Woodward Clyde Consultants prior to the construction of the Health and Human Services Center currently present on the site. Some of the findings included that the upper 10 to 12 feet of soil at the site consists of fill, which is mostly made up of silt and clay sands with occasional gravel pockets. Groundwater was also encountered in all the test points at a depth of about 10 feet. And it is our opinion that each of the 8 faults discussed in the report can produce an earthquake, resulting in significant ground motion at the site. The loose to medium dense sands and non-cohesive silts of the bay deposits generally are considered to be susceptible to liquefaction due to intense ground shaking. It is also our opinion that if cohesive soils such as clays or plastic silts are placed under the foundation during construction, then the potential for liquefaction will be greatly reduced.
The proposed construction plan details the redevelopment of the County Livewell campus, which includes a 55,000 square foot 4-story Livewell Center building, a 30,000 square foot 4-story parking structure, a 37,000 square foot area available for surface lots, and 3 acres of land for future affordable housing. The existing psychological services is not included in our scope. In order to overcome the site constraint of ensuring the existing health services and psychological services remain operational during construction, the construction must be separated into 2 phases. Phase 1 consists of closing the north part of the site as shown in order to build the new Livewell Center building. Once that is finished, the patients and employees from the existing building will be moved. Phase 2 begins by closing the south side of the site and demolishing the existing building in order to commence construction. Each phase will take approximately 1.5 years, with an overall project duration of 3 years. The schedule created outlines major construction tasks in sequence. The engineer's estimate consists of unit pricing for the systems needed by my team, which includes a 3,000-gallon cistern made of fiberglass to collect stormwater, tanks, and booster pumps, to name a few. The approximate cost is $61,000.
In conclusion, the Livewell campus can be feasibly constructed despite